like to thank you for taking the time to talk with us this evening, this afternoon, and participating in our Space Coast Oral History Project here for the Spacewalk of Fame. And would you please state your name, and then we'll begin with the interview.
My name is Lee Solid.
We were talking a little bit earlier about your education and what your aspirations were in college. I wonder if you could recount that for us here.
I really started, I went off to college to play basketball. That didn't work out. I was in a car accident and busted my leg up, and that was the end of my basketball career. My dad challenged me to do something greater, and so I went into engineering school with the idea that I would work in the mechanical engineering field with architects, and I couldn't afford to go out of state. There wasn't an architectural school in the state, and so I chose the mechanical engineering side of it. I really hadn't thought about the aerospace industry or the aviation industry or rocket propulsion or anything like that, even though I was aware of what was going on. And it was at the time of the Russian Sputnik and the United States' response to what they were doing in space. And but I didn't really have any aspirations of going into aerospace. And when I graduated from college, I did go to work for an architect in the state. It happened to be in the state of South Dakota. And I was there for a while when I received a call from a rocket engine company, Rocketdyne. I had interviewed them when I was in college looking for a job, but I never really thought about going with them. And they talked to me about what they were doing in rocket propulsion and deploying missiles in Europe, and they needed engineers to basically help them do this whole thing. And so they were offering me a position. Since I was standing there in 30-degree below weather and 3 feet of snow, and they were talking about sunny Southern California and swimming pools and great life out there, I packed my new wife and everything we had in a 2-wheel trailer and headed for California. And that's how it started. That was in March of 1959.
What was your wife's reaction about the move?
You know, growing up out in the plains of western South Dakota, we weren't all that familiar with cities, and in fact, cities kind of scared us. And where I was working for this architect was a relatively small town. And so the thought of going to Los Angeles was a little fearful, but you know, we were young. And
before we move on to your time in Los Angeles, I'd like to ask you just one quick question about Sputnik. Tell us where you were when you first heard the news of the launch of Sputnik.
Well, this being in 1957, I remember when we first heard about it, I happened to be in a design class, you know, at the school, and we talked about it. We rushed to the window to look up, knowing that we wouldn't see anything, but you know, yes, it was a topic of discussion. And I just happen to remember that's where I was when I first heard about Sputnik. And we talked a little bit about, you know, how do things go into orbit and what keeps them up there? And you know, we had that kind of a discussion just as students, and that was kind of the end of that.
Do you have any fears or anything like that from the launch of Sputnik, you know, in relation to?
You know, we recognized that we were in a competition with another superpower. And of course, see, this is at a time when Russia certainly was considered our enemy. And you know, we just were interested in whatever they were doing and whatever that impact might be on this country and our response to it. And so, but I don't know that, you know, when you're that age and you're doing what you're doing and trying to, you know, get through all these problem courses and an engineering curriculum, you know, I don't know that that there was any fear, you know.
What's your job description? You're hired by Rocketdyne. What's your first job description?
Okay, I don't recall what my first title was. I hired in, and one of the first things they did was they took us on a tour of the plant, where they were building rocket engines, assembling rocket engines and building the various components. They took us through and showed us how they built injectors and how they built thrust chambers and how they assembled turbo pumps, and those are the main components of a rocket engine. And I didn't have the foggiest notion. I hadn't taken any courses that even come close to rocketry. And so, you know, I'm learning about rocket engines the very first day I'm there, just looking at hardware. After that, they put me into engine test, and they were going to make me a test engineer. And Rocketdyne's test facility was in the Santa Susana Mountains, about 10 miles from the plant. And they took me up there and turned me over to one of the test supervisors and made me a test engineer. And one of the first things we had to do was learn about the engine, and so I learned about rocketry. They put me in a little school to learn propulsion, basic propulsion. And since we were going to be working on the Atlas engines, they taught me how an Atlas engine, you know, worked, and I became a test engineer. I wasn't a test engineer very long before they put me in the development side of it, the design and development side of it, but I stayed at the test site. And so I basically was put in the role of helping decide, you know, what we're going to test, how we're going to test, how long we're going to test, what specific test objectives, that sort of thing. And that was for the most part on the Atlas engine systems. For a brief time, I worked on an experimental engine with a couple of other guys, and that was a short-lived program, and they put me back on the Atlas after that. And then after about a year of testing and developing Atlas engines, they said, hey, we're trying to fly these things down at a place called Cape Canaveral, and would you like to go down there and help do that, at least for this new series of Atlas engines that we're trying to fly? I looked at a map to see where Cape Canaveral was. I'd never been east of the Mississippi. And you know, my wife and I talked about it. By this time, she had delivered twins, so we were at the beginning of a family. And we headed for Florida. And we arrived in Florida in May of 1960. In fact, my very first day on Cape Canaveral, it was the launch of that 9,000-mile Atlas. I can't remember what it was called, but it was the one where we were demonstrating the capability of launching one of these things 9,000 miles downrange. That was the very first Atlas launch that I saw, and that was in May of 1960.
What were your impressions of the launch?
Oh, I was incredibly impressed. I mean, from the moment that I got involved in rocket propulsion, I was impressed. Testing these things in the test stand, you know, immediately I realized that this is an exciting business. And the smoke and the fire and the noise and the rumble, you know, you set for yourself very short-term objectives, and that objective is get the next test off. You know, and when it's met in all that splendor. And so that, yes, I realized that I'm in an exciting business. And I never ever lost, you know, that feeling about the business, the whole business of space. And so that first launch, yes, that was very impressive to me. And then as I recall, the very next Atlas that we launched blew up. That was spectacular. And in the course of those early days, we saw lots of those that never made it very far.
Working on the Atlas engines and with the number of explosions that they did have, did other contractors, let's say the Martin people or whatever other contractor, did they ever give you any ribbing because of the amount of explosions?
Oh, there was always, you know, the competition between the contract in the rocket engine business. Our competitors were at that time really Aerojet. They built the engines on the Titan. Pratt & Whitney, not early on, but later would become a great competitor and still is to this day in the rocket engine business. Yes, but I mean, it's interesting that in those early days, the people in the launch business on the Cape side, it was like one big family. I mean, we knew that we were doing something important. those early Atlas launches were to develop a weapon system that was going to counter what was being aimed at us from, again, the Russians. And we understood that we were developing these systems. And as a matter of fact, 40 years ago, this month, September of 2002, 40 years ago this month, the first of the Atlas systems were deployed out in Kansas somewhere. And they would go on and deploy several more battalions, or whatever they were called, of these systems. But we knew what we were doing. We were developing, a system that was going to counter and be able to carry, a destructive force, against our enemy. Now, in the process, the Atlas starts becoming a space launch vehicle too, and we could put an Agena on there, and we could put Mariners and Rangers and other spacecraft that were going to go do things that were pure, space exploration oriented. And so we weren't just thinking weapon systems, even though, as I recall, almost every piece of data that we generated was still classified. Almost everything we had was classified. We learned early on, what the secret classification really meant. So those early days, again, you asked the question about was there competition and was there ribbing? Yes, but we also knew that we were going to blow these things up. We were going to have failures, and when you did a detailed investigation as to what happened, and fixed the problem and went on. I, with many others, recall traipsing through the palmetto bushes and the tules out there, picking up pieces that fell out of the sky and laying them out on the floor of one of the hangars, trying to figure out what did we do wrong. And generally we could figure out what was done wrong, and we'd go fix that and go fly again. So it's interesting, now that we're talking about that, we flew John Glenn in February of 1962. The next Atlas that was launched was from Vandenberg. It failed. Then there was another failure, and then there was an Atlas that blew up in Sycamore Canyon outside of San Diego. And we had to figure out what happened, fix the problem, and still keep the launch of Scott Carpenter on schedule. And we did that. And I remember those, by the way, as interesting days, because the failure at Sycamore Canyon was an engine problem, and we had to design the fix and certify, qualify the fix, and get it incorporated in the launch vehicle in time to launch Scott Carpenter, and we did that.
Do you recall specifically what the problem was?
Yes. Yes, we had the impeller, which is the inlet to the pump on the sustainer engine, rubbed. And in a LOX environment, you've got an ignition source and lots of fuel, and it immediately ignited. And so what we did was we designed a liner that if the impeller rubbed against it, it wouldn't create an ignition, or create sparks and an ignition source. And so we designed it, we built it, we installed it in an engine, tested it several times and qualified it, and put it into that sustainer engine for the Scott Carpenter launch. And that configuration, by the way, stayed with that sustainer engine for decades.
With John Glenn's launch, first human payload, what were your concerns when we're getting close to launch?
Well, let me back up even before that. I was deeply involved in the John Glenn launch because we had the engines, and I was the lead engineer over the engineering group by this time down here. And my feelings, started with the Redstone launches. I can recall the very first man we put on top of one of these, Virgil Grissom. I was really, we talked about it, even though I wasn't directly supporting that program. We talked about, hey, are we ready? I mean, we were still blowing these things up on the pad. Are we really ready to put a man on one of these things? I was so impressed with what might happen that I left that day, went home, got my little 8mm movie camera, and you couldn't bring cameras onto the Cape, so I went out on the jetty, at the end of the jetty, just to have a picture of this first manned launch, and I still have it. You know, I show it ever so often. This launch of the first man into space. I mean, I don't know that I expected it to blow. I just wanted a record of a very historical occasion. And yes, the thought, watching missiles blow up, and it happened frequently, and putting men on top of them, you know, at that time was, yes, you thought about what might happen. So.
But before we move in a little bit more with Mercury, I'd like to back a little bit up to your arrival here. Your first impressions of the Cape itself.
You know, I don't recall. We came here, rented a little house on Cocoa Beach. There weren't causeways except for one, going from Cocoa Beach to Cocoa, and that was a 2-lane road. Most everybody lived down south of Patrick or on Cocoa Beach or over in Cocoa, Rock Ledge. Merritt Island hadn't developed as a residential area. And so, you know, once a week we'd go from Cocoa Beach to Cocoa to do our grocery shopping and that sort of thing. And that's as recently as 1960. You know, whenever there was a downpour and a rain, why the traffic pileups were even greater because areas flooded. The road that went out to the Cape, it was amazing, you know, how piled up with traffic it was in the morning and in the evening. And you know, I remember those days. The Cape was a bustling place. There was activity in every hangar. You know, there were launch pads. All of the Atlas launch pads down, whatever it's called, Launch Row, were active. The Titan pads were active. They were starting to build the first Saturn pads. The Minuteman program was coming on board, and as you know, you'd see the donut come out of the hole, and then you'd see an explosion for the first 2 or 3 of those. There was activity out on the tip with the Mace. The Snark program, by the time I got here, was for the most part over, even though I think there was a Snark or 2 launched after I got here in 1960. So it was just lots of activity. And you seemed to know who was going to launch, and you'd manage to be somewhere where you could see this thing, no matter what. We were working full 2 shifts with a swing shift for some activity, and we were working weekends. We were working a lot of overtime. It was a busy, bustling place, and an exciting place to be.
Did you get called going home a couple hours later, called to come back out?
Oh yeah, but you know, we didn't have cell phones and things like that in those days, so you know, we did everything by telephone. But oh yeah, it was not uncommon at all to go home and get called back out. We didn't put a lot of restrictions on people's time in those days either. I can recall in long countdowns of actually going back and laying down and taking a nap in the blockhouse, you know, in some of those countdowns. And so we, you know, as time went on, why you tended to limit these things so that you didn't, you know, burn people out. But in those early days, we worked real hard.
That become a problem for, you know, your personal life?
You know, it did. It didn't get me and my family. It came close. Let me say it that way. And I realized that, you know, I was spending all of my time, day and night, 7 days a week, you know, to the exclusion of my family, and I needed to do something about that. And as they put me in more responsible roles, and so I wasn't, you know, the worker that had to be on the job all the time, you know, that changed, and I was able to recover, and I still live with my wife of 46 years, and my kids all survived those days, and they're all off and doing well.
Any particular reason why you elected Cocoa Beach rather than down south of Patrick or over on the mainland?
I don't know, but you know, it's interesting in my whole career, wherever the company moved me in whatever position I might be in at whatever level, I always moved as close to my place of business as possible. And that's kind of just the way it's always been. And I don't know that I had a great philosophy that said that's what you ought to do, but it just seemed like the closer you were to your place of business, the better off you'd be. And so we rented a little place in Cocoa Beach.
It wasn't in Conver Cove, was it?
No. In fact, it was right on, Atlantic goes north and Orlando goes south. It was on Orlando Avenue. It was one of those houses on Orlando Avenue down a few blocks south of the center of Cocoa Beach. It's still there. Still looks the same after 40 years.
Did you get involved in Cocoa Beach local politics at all?
Not really. Not in those early days. You know, we knew what was going on, and then in 1963, we decided that since the company in 1963 made me the base manager down here for the company, so I decided that even though when they originally sent me down here, they said we're gonna have you go down there for 6 months to a year while we launch this early series of Atlas, and then we'll bring you back here. And after I was here for a year and a half, they made me the lead engineer, and then another year and a half, they made me the base manager for the Rocketdyne activity here. So I now had the Atlas program and the Thor program, which became the Delta program, and the early stages of the Saturn I program. And all of those programs, from a Rocketdyne, rocket engine standpoint, reported to me. And so we decided that, you know, this might be a rather longer term effort, so we decided to buy some land on South Merritt Island and build a house, and we did that. So that was in 1963. By this time, Merritt Island is developing, and you know, and those first few years of the 1960s was a real explosion here in terms of housing construction.
How'd you find the schools for your children?
Great. We didn't. We got really involved. Our kids went to school on Merritt Island in elementary and middle school and on up into high school, and we found them to be great. We didn't have any problem at all. Now, we were parents that stayed quite involved in what our kids were doing in school, and but we didn't have an issue.
I'd like to head back a little bit to Mercury. For you, what's your most memorable moment of the entire Mercury program?
Well, of course, launching John Glenn was the highlight. We tried to launch him several times, like about 10 times. And every time we'd go through, you know, the countdown and the process of putting him in the capsule, and then something would come up and we'd have to deconfigure and try again. And I remember that, you know, all of the times that we tried to do it. But of course, you know, the day we finally did it was, yes, you know, putting him up there and that all being successful was certainly the highlight of the Mercury program. You know, and it's like all other manned programs. After that first one, why then you assume that, hey, now I know I can do it, and you go ahead and you do it. And you take the mission objectives and make them a little bit more strenuous, and that's what we did. And we soon realized that, you know, the Atlas system is a reliable system. Now, you know, we treated the hardware a little different when we knew we were going to put a man on it, and I'm trying to recall what we called it, man certified, I think. And when we would receive replacement hardware or we'd receive data, it'd have that stamp on it of man certified, and so it got an extra inspection, it got extra attention. You know, you'd like to think that all hardware for all Atlas systems were the same, but we gave extra special attention to the Mercury program.
Were you in the blockhouse during the launch?
No, as it turns out, I was in the blockhouse during many of the early attempts, and they made me the lead engineer, and so I assigned one of our other engineers to be in the blockhouse. I was there until the last moment, and then I left. As a matter of fact, an interesting thing that I was asked to do by our corporation, the individual who represented the International Aerospace Society, the term astronautique, headquartered in Paris. they had to certify that there indeed was a man in the spacecraft. And the guy that did that happened to work in our corporation. He was a member of that society. And I'm sorry that I butchered the name. I just can't recall.
That's okay.
His name was Dr. Dillaway. And I would take Dr. Dillaway out. We'd start in a blockhouse. And in this case, we said to Scott Carpenter, whose spot in the blockhouse was right next to ours. And I asked Scott to send word down to John Glenn to wave his hand in front of the window on the spacecraft. This would be after the tower was moved back and just before we had to vacate the pad. And we'd go out behind the ready room, and he would, through his binoculars, verify, as John Glenn would wave his hand across the window, he could verify for the society that there indeed was a man in this capsule. As a matter of fact, we did that for every one of the Mercury launches. And I generally was the guy that took Dr. Dillaway out behind the ready room and went through this little process.
Do you know if that process continued into Gemini?
I don't think it did. I think there were other more sophisticated ways of, of verifying that there were indeed men in these capsules.
Oh, goodness. As we're progressing through the Mercury project, and we have 4 Atlas launches. We get to Gordon Cooper's flight, and it marks the end of Mercury. What were your feelings, in regard to that?
Well, by this time, we knew we could do it, and even though you never had a launch without some concern, and I found myself thinking about everything that went on, every problem that we had during our test and checkout phase of preparing the hardware for launch. Had we seen every glitch, in the data? Had we explained everything that we found, every leak check, every functional test, every combined systems tests that we did? Had we really solved all the problems? And I'd always go through that little exercise, mental exercise. And so I don't know that for Cooper it was any different than any of the others in terms of what we felt about it. By this time, we were also getting involved in the small engine side of the house, and we're developing and building and testing the OMS and RCS systems for the Gemini capsule. And so we were already in the preparation phase for the next manned program, the Gemini program. And so I don't know, did we regret that the Mercury program was over, or did we have feelings that it ought to go on? I don't recall that we did. We knew what was going on here. We knew that this was going to ultimately lead to the Apollo. This is past the time that John F. Kennedy had made his proclamation and set the goal for landing a man on the moon in the decade, and we knew, where we were headed.
When you first hear the May 1961, what did you think when Kennedy said, we ought to go to the moon by the end of the decade? As an engineer, we were curious about how we were going to go about doing it. I don't think that we, and let me speak for myself, believed that we couldn't do it. This never loomed as an impossible task to those of us that were testing and flying launch vehicles and putting men, into orbit. It was just a matter of, how were we going to go about doing it? And of course, we in the rocket engine side of the house, we were in the process of designing and developing the very long lead items, and the engine happens to be the longest lead item in any missile system. And so we were well into that. In fact, while I was still at Santa Susana in late 1959, we were already starting to develop the F1 engine. I saw the first F1 engine test I take it back, it wasn't late 59, it was early 1960. It was probably in the March timeframe of 1960, before I was sent to Florida. And of course, after that first test, there was nothing left but a hole in the ground, because it just
it just exploded. It took all the hardware and it took the test stand, and like I say, all that was left was a hole in the ground. That was the first F1 engine test in 1960. And yet before the end of the decade, in July of 1969, those F1 engines powered men to the moon, you know. In fact, there never was a failure or even a glitch in the entire Apollo program with an F1 engine. But that's how the whole thing started, a hole in the ground.
When you see your first successful Saturn V launch, well, they're all successful launch. Were you
Awesome.
thinking back to that?
Oh, well, yeah, except that, you know, we'd come through the development program. We'd had a lot of problems in the development program. We'd solved those problems. And, you know, by this time, we were not only testing the engines individually in the test stand, but we'd clustered them into the stages, and they were being tested at the Marshall Space Flight Center, as well as this new place in Mississippi called, at that time, the Mississippi Test Facility. Today it's called the Stennis Space Center. And so, you know, by this time, you know, in the rocket engine business, you design it and you build the hardware and you change it and you test it and you change it again and you test it, and pretty soon you got something that's going to run when you start it up. And so by this point in time, by the time we launched one of these things, you know, we'd had a lot of test seconds on F1 engines and demonstrated their capability of running. Now, but, you know, since you bring up that first Saturn V launch, now there was a memorable occasion. That first Saturn V launch was awesome. You know, I can't imagine anything being more spectacular than seeing that thing fly for the first time.
Where were you?
I was in the firing room, you know, at the Pad 39, Kennedy Space Center.
Could you feel it in the firing?
Oh yes, oh yes. Yeah. In fact, we've never launched anything since that sent the, you know, the vibrations and the sound waves and had the noise level that a Saturn V had.
Let's backtrack just a little bit.
Okay.
End of Mercury, we're working toward Gemini. What are you doing in this time frame between 1963 and 1967?
There was a lot going on. We were still launching Atlas on space missions. I can't recall when the Atlas as a weapon system development program actually ended, but one of the pads continued to do that, Pad 11, for some time. And again, I don't recall the actual year that we went away from that, but it wasn't very long, and most of the Atlas launches were space-related launches. And by this time, I was responsible for the other programs too, and the Thor had become the Delta, and was launching that class of spacecraft and was very successful. We were building up on the Saturn I program, which Rocketdyne built the 8 H1 engines on the first stage, and by this time we were developing and building the J2 engine, which was the big LOX hydrogen engine, the first LOX hydrogen engine for the S4B. And so we were not only building up for that, you know, we were hiring the people to do the test and the checkout, and the engineers to write the procedures and all that stuff. So I was building up for the Apollo program during those years. In fact, it was during that time that a decision was made that rocket engine people should be the ones to test and check out the engines, and so we took on a role that we hadn't had before. Before, we had just done the engineering, and the technicians were the one from the vehicle contractor were the ones who, you know, did the work. But with the Apollo program coming on board, why the decision was made. In fact, I still have to this day an agreement that I wrote putting us in that role that was signed by Werner von Braun and Dr. Debus. And so this is the kind of things that I was doing, you know, implementing a new role for Rocketdyne and the engine people on the Apollo program. And so that's what we were doing.
As you know, you arrive in 1960 and it's a much smaller workforce. You know, everything is Capeside. There's no KSC yet.
Right.
We start the construction, you know, over at KSC. You get many more people coming on board with Apollo. For you, does this change what it's like working out there? I mean, the vast numbers of people that have been introduced, does that alter in any way your work experience or how you feel about the space program in general?
Well, you know, we went through the transition of going from programs that were largely under the auspices of the Air Force to this new organization called NASA. It started out as an extension of the Marshall Space Flight Center, that Launch Operations Command or group. And then, of course, NASA then becomes a center 40 years ago in 1962. And we had to start, you know, learning how to work with you know, a new group, a new organization, a new customer, so to speak. And at the same time, since they were new, we were actually helping them, you know, in informing how you do business and how you work. Now, once the decision was made to go build this incredible facility over here and buy the land and, you know, design it, yes, you know, it became a very interesting thing for all of us, because we all knew that one day, especially in my case, being in the rocket engine side of the house, the decision was already made that Rocketdyne was going to have the engines on the first stage, the second stage, the third stage, and even engines on the command and service module itself. And so we knew that we had a big future and that we were going to be deeply involved in this program. I personally, you know, decided that, hey, I'm going to know as much as I can about the whole program, and when people would come here, I would drive them over to this new test site and show them the foundation of this incredible building. And we, you know, I had all the buzzwords. I knew how big it was going to be and how deep they had to dig and how far they had to drive the pilings down and how much, how many millions of tons and cubic yards of earth they had to move, and I knew all that stuff. And I stayed pretty close to just what was going on in preparing for this thing we were going to do in taking men to the moon. Now, early in that program, of course, the plans were much more, you know, grandiose. We were going to have many more launches. There was going to be a whole lot more testing and checkout of the various pieces of the Apollo here. So a whole test area was built down south of the headquarters building in NASA. And so, you know, there was a broad range of things that were going to be done, many of which, as far as the tests were concerned, was not done. But that didn't diminish the fact that, you know, we had to build up to put this whole system together down here, test it and check it out and put astronauts in it and launch it. And yes, the population of the place exploded. And that affected everything. Roads were built, you know, and shopping centers went in, and housing developments sprung up all over the county, and every area, you know, benefited from this incredible program called Apollo.
You know, coming from a contractor that's working with both the Air Force and NASA at one time or another, any major differences in how their relationship is to the contractor? You know, how they...
Well, I used to think that the Air Force was a little more dependent upon the contractor in terms of the day-to-day decisions involving the hardware and how you tested it and checked it out and launched it. But see, even the Air Force had their specialists, their SE and TD, so to speak. They had space technology laboratories helping them. Those folks, STL, became the Aerospace Corporation, which exists to this day, which are the technical experts that, you know, that assist the military people, the Air Force, largely the Air Force, in what they do. NASA, on the other hand, you know, hired engineers and started getting involved intimately in the in the engineering and in the processing and the testing of the hardware. And so I guess, but when I look back on it, working with them was not that much different. I don't know how I got this way, but the customer is the customer. And you had to work with the customer at whatever level. Whether you were, testing the hardware and you were an inspector on the hardware, or you were a technician or whatever it was. One of the things we trained our people as a contractor is to never forget who the customer is and who we're serving, who's in authority here. And you have one role in life, and that's to make that customer successful.
Did you ever consider, I know that at this time, contractors are making significant, or at least sizable, salary-wise, more than the NASA civil servants. Was there any moment at that time where you had considered leaving the contractor position and becoming a civil servant?
No, but a lot of people did, and much of NASA. And there came a point in time when there was parity in the salary structure between the government. Early on in those early days, yes, it was not. And the appeal for a contractor's engineer to move into NASA was generally a position of responsibility that he couldn't get, he or she couldn't get in the contractor organization, or some other reason. I so enjoyed being an engineer and then an engineering manager in a high-tech company, in a high-tech environment, and that's what rocket engines were, that I never thought about it. And did I have opportunities? Yes. I had many opportunities. People would come to me and make me offers to go to one company or another, or to go into NASA. And I never ever considered it. I just,
You brought up he or she. Females at this particular moment. Do you have any female engineers for Rocketdyne at this time?
In those early days during the Mercury era or the Gemini era?
Gemini and Apollo era.
We were well into the Apollo era before there was a female engineer for our company here at the launch site. As we moved on into the shuttle program, why, it certainly was not uncommon. We had several. Still do.
So early on, the females are going to be in more like a secretarial capacity,
right.
And that's
right,
yeah.
right. I cannot, since you asked the question, I don't recall the first. I probably ought to remember, but I don't recall the first female engineer in the contractors that we worked with, because, see, as a rocket engine organization, we were always attached to some vehicle contractor who generally had the primary responsibility for the test and the checkout and the launch of that system, whether we're talking Atlas or Delta or the Gemini or whatever we might be talking about. And so we always worked real close with the vehicle contractors. And I don't have in my recollection the first female engineer in the contractors organization or in our own.
I'd like to pause here for a moment because we're at 44 minutes, so I'm going to have to turn that table real quick. So
okay.
Just stop here for a second. Okay. Now,
Okay.
Could we discuss a little bit about Rocketdyne's involvement with the Gemini program?
Rocketdyne moved into the small engine business in the early 60s. And so we had the orbit maneuvering system and the reaction control system on the Gemini capsule itself. This was a subcontract to the McDonnell company, and all we were doing was providing just the nozzles, the engines themselves. The rest of the system was provided by McDonnell. And so We weren't near as deeply involved in the day-to-day operations and the test and the checkout and that sort of thing on the Gemini program, but we were providing some rather significant hardware to it.
And McDonald, being a spacecraft corporation as opposed to Convair being a booster corporation, did that present any particular problems to you in the way you worked with them, their mindset?
Well, it was a little different, but not really. As an engine manufacturer, a rocket engine manufacturer, we provided hardware to a vehicle contractor, whether it was a guy building a vehicle that you're going to launch, like General Dynamics Convair on the Atlas, or Douglas. At that time it was just the Douglas company on the Thor, or McDonald company on a capsule. We were providing the propulsion units to those vehicles, and so the relationships weren't that much different. It's just that a rocket engine on a vehicle was a little more extensive system, and so we had a little bit more actual hands-on work to do on a rocket engine than we did on the little engines that we put on a capsule.
For you, what's your most memorable moment of the Gemini program?
Well, it has to be the spacewalk, simply because that was the first, and there was concern about doing it and the ability to do that and the effect on a man in space. And so, I recall that there was a lot of firsts in the Gemini program, and most of those firsts were there to prepare ultimately for the Apollo program, and that program did it very well. In fact, the Gemini program probably is a little underappreciated and under-recognized for its contribution to manned space.
We had talked a little bit about females out at the Cape in the early years. Kind of females in Mercury, what's their position within the Rocketdyne Corporation?
In Rocketdyne proper at the home plant, I'm sure there were female engineers. I don't recall working with any female engineers when I was in the test and development before I came to Cape Canaveral. And we did not have female engineers here during the Mercury program or any of the Atlas program or during the Gemini program. I do not recall the first female engineer in our operation until late in the Apollo program.
And minorities, does Rocketdyne employ any African Americans or Hispanics that you can recall during this early time?
Oh yes. Being in Southern California, of course, Rocketdyne was as diverse in its hiring practices as any company. In the engineering ranks, Rocketdyne is a high-tech company. And as such, it had its favorites, the schools that you went to and interviewed and hired new engineers. And some of those schools happened to be black colleges, and so we had a number of minorities in the engineering ranks in our high-tech company. I don't recall really in the field and at this location here how many or when the first was, but
John Glenn, after John Glenn, you had indicated earlier that there was a few explosions of Atlas's between his launch and Cooper's upcoming launch. Wonder if you could tell me what happened in developing and changing and the astronaut's role during this several-month period between Glenn's launch and Carpenter's launch.
After John Glenn's very successful launch, we blew an Atlas at Vandenberg. We had another failure, and I don't recall the details of that failure. But the big failure was an Atlas that was destroyed, and the whole test stand was destroyed at Sycamore Canyon. And the cause of that one happened to be a sustainer engine. When we started it up, the inlet to the pump rubbed and created an ignition source, and we immediately had an oxygen fire, and that just destroyed the whole vehicle and most of the test area. And of course, you know, you look at something like that and say, how do we know something like that won't happen on the next manned launch, which happened to be Scott Carpenter's launch? And so we immediately went into an investigation, and we redesigned the inlet to the sustainer engine. We installed a Cal-F liner. We designed it, built it, tested it, qualified it, and put it on the engine that we were going to launch Scott Carpenter on. And during that process, since John Glenn had flown successfully, he and the flight director at that time was Chris Kraft, would come to my office and check on the status of where we were in our recovery program. And so that's when I kind of got to know those guys. They were very interested in how we were doing and what we were doing, and whether or not it was going to impact the second Mercury launch.
And would Glenn be the astronaut that you had the most interaction with throughout Mercury? Or? Probably,
yes, because we had, as I said, we tried to launch him several times, and so we probably got to know him and Scott Carpenter. As a matter of fact, Scott's position in the blockhouse was right next to ours, and so we got to know him quite well.
Now, as things are changing and Apollo comes online, do you notice a difference in the way the projects are managed, the smaller Mercury and Gemini programs versus, you know, Apollo? You know, is there a big change in the way NASA is addressing its contractors?
As time progressed, from program to program, the level of the decision making did seem to move upward, and by the time we're into the Apollo program, why program directors and project managers and center directors and, you know, relatively high-level people are much more involved in the decision making, the commitment to launch, the commitment to test, the establishment of investigating boards in the case of a failure and that sort of thing seemed to move up organizationally as we moved, you know, towards the culmination of the Apollo program, and it would only be natural. You know, the Air Force in the early days was probably more dependent upon the contractor to make the day-to-day decisions. When we would have a failure, we could turn around rather rapidly, you know, decide what happened and what needed to be done to fix the problem and move on into the next stage in the program. But over time, that progressed, that decision-making process did indeed progress up the organizational chain.
Did that frustrate you at all?
Well, you know, I was kind of moving up the organizational chain in our company with it, I guess, and so I can't say that it really frustrated me. It just was a change.
Gemini is over, and we're gearing up for Apollo. January of '67, of course, there's the Apollo 204 fire. I wonder if you could discuss where you were when you heard of the accident and the immediate mood over at the Cape for the next month or two after the event.
Well, we in Rocketdyne, because this was the Saturn I, and we had the first stage engines, and we had the second stage engine, the J2 on the S4B. And this was a rather significant test that was going on that day and well into that evening. And so we were quite deeply involved in that. I had left the complex. I was again, as I think I've already said, I was the base manager for the Rocketdyne effort down here, and I stayed in touch with what was going on, but I was not at the pad. I happened to be at home that evening, and I was just preparing with my wife to go to a party. And just as we were leaving, I get the call that there's been a major incident. And it was some time before anybody was willing to say that the crew is lost. But, you know, those of us that knew what happened out there had pretty well, you know, assumed that. And so I stayed home and just stayed on the phone and stayed in touch with our people at the pad as to what was happening and what was going on. And so, yes, you know, I remember it like it was yesterday, because it was an incredible moment in the history of the Apollo program. But we weren't directly involved. We Rocketdyners were not directly involved in it.
And you know, with the fire, was there a thought that this might seriously hamper the progression of Apollo?
Well, yes. I guess it isn't the kind of thing you really thought about at the time. You knew that you'd had a major accident. You knew that you had a major situation that had to be resolved. And, you know, as is always the case, you know, the more you learn, you know, the first data that comes out, you know, isn't always the right data. You know, you've got to learn what really happened and then make decisions as to what you're going to do to fix the problem. And that's what was going on. Were we Rocketdyners interested? Of course we were. You know, we were deeply involved in the vehicle that's going to launch this thing. And it was our sister division that was the designer and developer and builder of the command module where this accident occurred. And so we, of course, myself, I'll speak for myself, was very, very interested in what was going on, and could we recover? Could we indeed fix this problem and still make our mission to the moon in this decade? And yes, those thoughts all were very much a part of our thought processes.
I'd like to go off how we had been going, and I'd like to ask you something a little more just general. World events that are occurring in the 1960s, and national events, civil rights movements, involvement in Vietnam and things of this nature. Are you keeping pace with all of that, or are you too absorbed in what's going on out there?
Yes and yes. You know, I'll speak from a personal standpoint. You know, I stayed in touch with what was going on because we're still in a race with the Russians, and we're interested in what's going on with them and how we are doing and how we're progressing. At the same time, we are focused on what it is we're doing and preparing this hardware to launch these people, these guys to the moon. And there was a very well-established process. One launch built on another, one step in the process built on the previous step. And all of this was very well laid out. And any glitch in that process, you know, you certainly considered, you know, have we interrupted the whole flow? You know, are we really going to get to where it is we're going? And yes, we thought about that, and we worked those issues, and we were focused on that in what we were doing, but not to the exclusion of everything else that's going on in the world. Did we think what we were doing was the most important? Yeah. You know, did we want to pick up a newspaper and read what's going on in the space program and see it, you know, in a rather prominent way? Yeah. You know, that's true. We did.
We need to pause here because this tape is ending, so let me go ahead and stop this and stop that and
okay.
reinsert some new tape real quick. Okay, as we start our second tape, let's move into the Apollo era itself. Apollo 7 is a Saturn V launch. Can you compare a Saturn V launch compared to a Saturn V launch for me?
Well, the first Saturn I or 1B that was launched was rather impressive because, you know, we were watching Atlas and we were watching Titans. They were the biggest things launched from the Cape in those days, and we were watching this new solid propelled system, the Minuteman, and, you know, we were watching launches. You didn't work at the Cape and not run out and watch every launch because it's just a spectacular sight. The Saturn I, of course, was bigger than anything, and so yes, we were rather impressed with that. Compare it to the Saturn V, nothing compares to the Saturn V. I don't think anything's ever been launched anywhere that compares to the Saturn V, and I'm including, of course, the Space Shuttle. It was an awesome sight to see something that large leave this Earth. And so the Saturn I and 1B were impressive sights and impressive launches.
Were you always in the Launch Control Center for all the Saturn V's, or were you ever outside where you could actually see one?
No, I think of all of the Apollo launches up through the time, I left here in 1970 and was gone. I came back since the operation here reported to me in the company. I came back for every launch. But up until the time I left, yes, I was in the firing room for all of the Apollo launches up to that point in time, when I view them from outside. And whether you're in the firing room or whether you're outside, a Saturn V certainly left an impression. The noise, the vibration, just the overall spectacularness of a Saturn V launch, I'll never forget.
How is it on your body?
Well, you felt it. You were amazed that that there could be this kind of vibration coming from something 3.5 to 4 miles away from you, and have it be that intense.
For you, which Apollo mission is the most memorable?
Well, it has to be Apollo 11. All of the readiness meetings that we had leading up to it, and all of the test and checkout. We were very sensitive to the fact that we're putting men on here that go to the moon. Apollo 8 was spectacular, no doubt about it, but nothing like Apollo 11. I mean, they did everything on Apollo 8 except actually land it. But most of us felt that that's where the real risk is in this whole mission. Anyway, and so what we did in Apollo 8 was very impressive, but nothing like Apollo 11. I mean, I'm sure I and millions of other people, see, it happened here, the landing happened here like at 3 o'clock in the morning. But I got all my kids up and plunked them down in front of the TV so that they would not miss this historical event, because, and I remember that like it was yesterday. It's, the Apollo missions were all different, they were all significant, they were all important. The attention that we gave to the hardware was the same. The fears that we might have regarding the risk, was pretty much the same, but nothing like that first one.
And during the launch of Apollo 11, what's this area like with people coming into view?
Well, this was such an event that, and I don't know where it stands in the record books as to people viewing this event, but everybody wanted to have their eyeballs on this historical event firsthand. So there were lots and lots of people. My wife didn't come out to view lots of launches, but she wouldn't have missed this one, So I made arrangements for her to view it from the viewing stands. It just, yes, it was. There's no doubt about it being, the centerpiece of the whole program.
You leave here in 1970. Do you sell your home and everything, or?
Yes. Now you see, in 1970, people are realizing that, the Apollo program is tapering off, and so the boom is over. And like in our company, Rocketdyne employed some 20,000 people at its heyday of building F1 and J2 and H1 and all of the other engine systems. We had plants in McGregor, Texas, and Neosho, Missouri, and we were starting to close plants down. And 20,000 people by 1972 would become 4,000 people. And so, we, like all of the other contractors that were so deeply involved in the Apollo program, went through a rather significant reduction in force. But you realize the budget on Apollo. We reached whatever it was, 30-some billion a year, on the Apollo program, and we've never come close to that since. But that's just the kind of a commitment that we had, and so that meant lots and lots of people, lots and lots of activity.
Did you ever consider that there might be a very real possibility that you yourself would face unemployment in this downturn?
No, and I don't know why. I guess my formative training was one of just total optimism. I never ever thought about failure. I never thought about things like that. The company moved me from the launch site back to the main plant and promoted me at a time when they were going through these thousands in reduction of force, and there just never was any discussion that led me to believe that I had any fear. And so I moved the family back to California and went to work in the position that they had for me there. It just so happened that the field sites reported to me, and because this was a rather significant promotion for me after Apollo 11. Well, I was here through Apollo 13. And the field sites, the test sites at Huntsville and Stennis and Vandenberg and here at the Kennedy Space Center still all reported to me in the role that I had at the home plant.
Individuals that were laid off, I'm sure people that you worked with rather closely out here, when they were laid off, do you know into what areas they decided to attempt to secure employment?
Oh yes, they went everywhere, and yes, and there were many sad stories. There were engineers doing things, working in areas that were far below what an engineering degree, should be worth. And yes, still as one employed at a reasonably senior position in the company, I can recall getting lots of calls from people who were going out the door, just begging, pleading for jobs. But at that particular point in time, every contractor involved in the Apollo program was reducing, and there just weren't positions out there. And the housing market, there were. I can't tell this story because I was able to sell my home and make a little profit on it and move to California and buy another one. But there were people who had to walk away from homes that they had built here, during the heyday. And yes, there were some real low, the early 70s was a low time here. It certainly wasn't a boom area.
And when you go back to California, what's your, what are you gearing up for?
Well, I was moving back into the management structure of a company that was going to go on, and by this time in 1971, in fact, when I got back to California, we were in the proposal phase for the Space Shuttle main engine, which was going to be the next space transportation, manned space transportation system, and we won that, and I was part of those early days in the Space Shuttle program. And designing and developing and testing the Space Shuttle main engine. And so, we were going to move forward. It certainly was not going to be at the pace that we had just experienced on the Apollo program. And the Space Shuttle main engine was now going to be our main line of business. We would finish launching all the F1s, the J2s. And when we finally launched the Apollo Soyuz, that was the last of the F1s, H1s, and J2 engines that were launched. And so we were now, focusing on, we were still building and delivering Alice engines. We were still building engines for the Delta. We were branching out into some other areas because the early 70s was also the time of the first energy crisis. And so we and other high-tech companies ventured into the energy business. And another thing that was happening about that time was the development of new high-tech weapon systems, i.e. high-energy lasers. And a high-energy laser is just another version of a rocket engine. And so we were a natural to get into that. So the company that I worked for got involved in designing, developing, and building space shuttle main engines and various programs in the energy business, as well as high-energy lasers.
So it was still a productive period in the 70s, just more diverse.
Oh yeah, and we just went on to other things. And then, of course, as the shuttle program, our sister division won the orbiter itself, and so, you know, the design, the development, and the early testing on the orbiter began, and we were all building up for the shuttle program. And so after the downtime in the early 70s, why, you know, the buildup and the facilities are modified here to accommodate the shuttle, and so, you know, things started to change here as we built up for shuttle.
Emotionally, is it as rewarding working on the build-up to shuttle as it was in the early periods for you?
No, and of course, you know, I'm getting older, and I'm, you know, maturing in this whole thing, and, you know, as you move up the chain in management, and you get further and further from the details of engineering, you know, you get to worrying other things, you know, contracts and costs and rates and people problems and, you know, that sort of thing, acquisitions, and so you start thinking about other things and get involved in managing other things. The shuttle program, you know, we knew that that's the next big program, and it was very significant to our company, since one division had designed and was building the orbiter, and another division was building the space shuttle main engines, which, by the way, you know, is the highest tech part of the space shuttle program, and is to this day. In fact, that space shuttle main engine is probably the highest technology, if you can rate it, device ever built by mortal man. It's an incredible machine, and there's no propulsion technology has come along to this day that surpasses the capability and the efficiency, the power densities, etc., that come out of the space shuttle main engine. But you asked the question about the shuttle program. Getting up to that first shuttle launch was almost as exciting and demanding as moving up to that first launch to the moon, because we'd had so many problems with the engine. You know, seemingly unsolvable problems with the engine in developing it, and here we were, you know, delivering flight engines to the first shuttle, and we had all kinds of problems with the shuttle, you know, and getting that thermal insulation system on there, and so there were so many problems that I suppose from an emotional standpoint, I got to be honest with you, and I say that the only time that I ever really wept was when we launched the first shuttle.
And what were some of the major problems that you had to overcome with the development of this new engine over the F1s and everything?
Well, we were dealing with speeds and temperatures and pressures unbeknown before. This is a high PC chamber pressure, a 3,000 PSI chamber pressure engine. There was never any engine before that beyond 1,200 PSI. We were using hydrogen and liquid oxygen and liquid hydrogen, and even though we had that technology in hand with the development of the J2 engine, we had never done it with the kind of specific impulse goals and performance goals that we were shooting for with the Space Shuttle main engine. We also were developing a system that's installed at the tail end of an airplane, and so you had to concern yourself with weight. Like, we didn't have to concern ourselves that much with weight. So we had to develop new materials. We had that were lighter, yet strong enough to take these incredible pressures. The fuel pump put out, as I recall, you know, 7,500 PSI. The LOX pump well over 6,000 PSI. So we were dealing with pressures, and so you have to have materials that will withstand those kind of pressures. You know, at the same time, you take a little old turbine blade that's an inch and 3/4 long, and at one end of it the temperature is minus 260 degrees, and at the other end of it, 1 3/4 inches away from it, it's 1,500 degrees. And so you got all kinds of thermal stresses that are just incredible. And so those early problems, we couldn't seem to develop turbine blades without cracks. And we went through all kinds of process changes and approaches to developing turbine blades. So turbines and pumps, weight, the ability to test this thing. We went into a program where we were going to test the components, but we had to develop systems that would create 8,000 PSI so that you could test this component. So we came to the conclusion that we're better off testing components on engines. So just go ahead and build engines, put the components on engines, and let the engine infrastructure be the test bed for all the components. We were dealing with a control system that was far beyond anything. When we look at it today in terms of technology, it's rather antiquated. But at that particular point in time, we were pushing the envelope on control systems that would start this thing and run it and throttle it and so forth, that were far beyond what we dreamed it would be. So we had lots and lots and lots of technical issues that we had to deal with. And so when we finally decided we're to the point where we can ignite this thing and put men in it and launch it, many of us were like, drained emotionally from just all of what it took to get to this point. And so that's why I say it was probably in all of my experience. See, by this time, because of the problems with the Space Shuttle main engine, the company moved me to the Marshall Space Flight Center, which were responsible for the development of the main engines. And so I set up an office there and worked with our customer at Marshall. And then when the hardware started flowing here, they asked me to come back here and set up the operation here that would test and check out the Space Shuttle main engines and help us launch this thing. I had not in my career path intended to come back here to the launch site, but the magnitude of this program was such that I did what they asked me to do, and that is come back.
And when you come back, it's markedly different. The Cape is not as active as it once was.
Right.
Could you reflect on the changes that you see here?
Well, yes, and launch pads had closed. There was still Atlases being launched, but very few. The Delta program was now completely a space launch program, and it was still a workhorse for that class of payload. Others that I used to watch, they'd all gone away. The focus was on the shuttle. There was a Titan program that would launch from time to time, especially military satellites. But yes, things had changed quite significantly. And of course, I'd been part of the change. It just wasn't here locally. And budgets were coming down in NASA. And most of that was being spent on the shuttle program. And so yes, our focus at that point in time was indeed on Space Shuttle.
When you wander out to, let's say, Complex 14 today, how do you feel?
You think about the past. 14 is a good example because there isn't a lot left there. But, you can't help but reminisce and think about the old days and what was there and the things that went on there. And now that I'm retired, I go to retirement luncheons and breakfasts and talk to old-timers that worked at these places, and we reminisce and talk about the, quote, good old days.
You say were the good old days for you personally more rewarding than towards the end?
Oh, I don't know. Youth has a lot to do. Youthful enthusiasm, and it was exciting to be a part of, and the launches drew named people, and so you got to meet people like Charles Lindbergh and Jimmy Doolittle and people like that. And see, I remember these things, and I was into management at a relatively young age, and so I got invited to various and sundry forums. And yes, it was exciting. I wish I'd have had pictures taken and gotten autographs. I wasn't much on that sort of thing, but I remember these were exciting times to meet people like this. I ran into people like Jack Benny at the airport, fumbling his luggage, and so I went to help him. And there's a lady there with a camera, and I said, "Hey, just take a picture of us." I've got a picture of me, and I mean, things like that just happened because of the excitement associated with launch and putting men on the moon, putting men into space, and that was an exciting thing, and I was a part of that excitement. Was it more rewarding? To the extent that in those early days, the decision-making process was a little bit lower level. There was a time when I, as a test engineer, decided whether or not we tested an engine. There came a point in time on the Space Shuttle main engine program where, it was a project manager level or above that decided whether or not we committed to test that engine that day. And so, yes, the freedom that we had and the decision-making capability that we were afforded. But you realize in the early 60s, most of us were relatively young. I mean, it was a relatively young workforce. And there was an awful lot of people that had just come out of college that were deeply involved in the design of rather sophisticated systems. And so.
One item that we haven't addressed at all, launch parties. Did you attend a lot of launch parties?
I really wasn't much into that. I attended launch parties. I'm just not a party animal from a personal standpoint. The launch itself and the immediate satisfaction and gratification associated with doing something successful, was basically the party for me. Did I go to launch parties and celebrations? Yes. Was I really highly involved in them? No, I wasn't. If we had a parade in Cocoa Beach to honor the astronauts that had just flown, yes, I went to those. I took my kids. I wanted them to see these space heroes, and I have pictures and 8mm movies of these events. But from a party standpoint, see, one of the things that I've always said about the business that we were in, whether I was in the design, development, and test of rocket engines, or whether we were launching something, life was a series of short-term goals. Our next goal was this successful test or this successful launch. And when that goal was met, it was met in all the splendor of smoke and fire and rumble. I mean, it's splendid. And that goal was met that way. And immediately upon that goal being achieved, you went on to the next short-term goals. And so not all business is like that, where you have this series of short-term goals that are met in all of the splendor that I just described, So that's why I say it's an exciting business, And I'll never regret for 1 second having been involved in it for these last 40 years.
We've only got a couple extra minutes here. Is there any area that we haven't addressed that you'd like to remark on before we conclude?
No, I think we've covered things pretty well. It seems like we were always thinking about the future. Even when we were so focused on Apollo, we knew there had to be something beyond sending men to the moon. And so there was always consideration being given to what's next, what's beyond. And I was always interested in all of the various approaches and all the various ideas that people had. And I know even in those early days when they talked about space stations, it's very interesting that some of those early thoughts were very much in tune with what we've actually gotten today. But you know, we were always thinking about the future and where we go from here. I guess I really believe we thought at that time that we would be a whole lot further down the path of going to Mars or going into space and exploring a whole lot further than we have explored from a human standpoint than we are today. I guess I really believed in, let's pick a date, 1968, that by the year 2000 we would be sending men to other planets, specifically to Mars.
Well, I'd like to thank you very much for participating in the project.